All right, hope you had a fantastic lunch and you're ready to learn. Our speaker today is Matthew Seal. He works at Netflix and he's going to teach us about how to control Jupyter notebooks with Python.
Thanks. All right. So first thing, just a little bit, if you want to follow along these slides later or go look at anything in more depth, because I'm going to be going through a lot of slides, there's a tiny URL here, and then the very last page will have it too, so you'll be able to see what was up here. So we're going to be talking today about Programmatic Notebooks with papermill. Papermill is a library, and it's in Jupyter space, and I'll talk about what that means in a minute. So first off, who am I? My name is Matthew Seal, as the intro very kindly stated, and then I work at the big data platform team at Netflix. In particular, I work on scheduling and orchestration, and we have a big overlap of that with notebooks, because we actually do a bunch of scheduled notebooks, and we kind of make that easy for our users to do. And so that kind of leads me into, well, you said you're a big data platform team member. What does that mean? Not everyone knows what that means, including some people on data platform teams. And we were like, what am I doing to help people? So the way I like to kind of state this is like we're helping build these data platform services that help people kind of get out of the way of people doing their job. So we have lots of data inputs from events, from users, from system metrics, and the user needs to be able to collect those up, say something about them, either put them in another system so someone can live query them faster, build a report, do some machine learning on it, feed it back into another ETL system. All these things, they need tools to do this because it's a complicated problem, but the conceptual problem that the user's trying to solve is relatively simple. I want data from A to B. Why is it so hard not work? So we try to make it easy so they don't have to come ask us why nothing works. And so some of these tools and these things I'm talking about, this is all open source stuff that we use to help make that possible. So in the short version of this, the data platform tries to open doors for folks, just not that door, because it's scary. Everything that I'm presenting here is open source projects, so you can go see the contributions there. I'm a maintainer in both the Jupyter space and the nteract space, and I do the releases for papermill, so if you have papermill specific things, definitely I can help you or point you to the right discourses. And all these things have been contributed by Netflix. So we have a notebooks team, which contributes a lot of code in this space, and then I also contribute, and a few other members that aren't on those teams specifically contribute. All right, so first thing is, how many of you know what a notebook is? That's awesome. That means I can go fast enough. How many know what the difference between a Jupyter notebook is and, say, a Zeppelin notebook? Yeah, like 5% of you. Cool. That's part of why I'm here. It's a little bit talking about the Jupyter-specific things and what the ecosystem allows to enable this kind of functionality that I'm about to describe. So a Jupyter notebook, in its most basic form, something like this. You see notebooks. But the Jupyter ecosystem, as opposed to some of the other notebook ecosystems that have similar functionality, is really about the specs that enable the protocol between a client and the actual runtime that's running your code. So there's a lot of APIs that have been established on which these systems talk to each other. What this means is that in a notebook like this, when you're working on one with a rendered Repl of some sort, like Python or Scala, because in Jupyter everything is going over this communication protocol that has a fixed standard about how to execute code and markdown and other things. It means you can make kernels in many different languages. So the kernel's the piece that actually runs the code in the back end. It also means you make clients of many types. So I'm showing you here, this is a UI from an nteract, which is a kind of place that builds a bunch of components for using in notebooks, and they have a collection of those components that makes a UI. Similarly, there's Jupyter Lab and Jupyter Classic are both UIs on Jupyter, and a lot of platforms have their own proprietary UIs that talk on the same protocols, and they can provide a look and feel matching their platform. So a little bit on what a notebook is. I'll go quickly here because you all kind of know, but it's basically rendering the interactions with a Repl being a real-time interactive process where you're sending it strings and it gives you back executed code results. And notebooks in this space are really handy because it gives you a place where there's code, logs, documentation, execution results all in the same interface. And not just the same interface, in the Jupyter ecosystem, it's also in the same file. So the file format that gets saved when you're running a notebook or saving a notebook is saving into an IPMYB file, which is basically a glorified JSON file with a schema. So I'm going to skip through the breakdown a little bit because I think most of you said you're familiar with notebooks, but here's some kind of like high-level concepts in here. You have like a save and indicator, a code cell that generates some displayed outputs. In this case, we generate a graph from some code, and it's all saved in the same document. If I share this document with someone, that document embeds this information inside of it. And the places where notebooks actually have good wins is they're shareable, they're pretty easy to read, you get this documentation with code pairing, and the outputs are associated with that code as well. And it's also a familiar interface for many users. It's got enough popularity that you can give someone a notebook and they kind of know what to do and how it works, even if they don't know that particular flavor of notebook. And notebooks are growing even more in a multi-language sense. So while everything I'm showing you here is going to be Python, there's also other languages that can run notebook code in the background, including multi-language kernels, which are kind of a fun thing if you're ever looking into it. So how does a Jupyter notebook actually execute code? We're going to talk about this a little bit first so that we can explain how the tools we use work. So a very high level, it's more complex than this, but this gives you a kind of visual idea of what's going on. As a user, when you're typically using a Jupyter UI of some sort, you're talking to your UI in a browser. That is talking back to a server, which is hosting the UI and some basic APIs for it. And then that server is responsible for ferrying messages to and from this thing called a kernel. Now, a kernel is a terrible name for what this Repl wrapper is, because if you're in machine learning, there's a different thing that's a kernel. If you're in OS, there's another thing called a kernel. There's a lot of kernels. In this case, when we're talking about kernel, we're always going to refer to a Jupyter kernel, which is basically a command that wraps the REPL that accepts the communication protocol that Jupyter has defined. All right, so we're going to talk a little bit about traditionally where notebooks come from, because it's important about where it's going and what it's being used for now. So back when I first started using Jupyter notebooks, which is before I knew I'd be involved in Jupyter, a long time ago, it was around in data science, it was really popular. And the reason why was because you could explore and analyze, not really knowing what your end result needed to be, but knowing you needed to try a bunch of things and that they were expensive computations that you needed to do. So the really good things about notebooks are you get quick iteration cycles. I can run just one snippet of code on the same live context over and over again until I get it right, or until I find the right data, or until the model I chose did the right thing. You can leave all your expensive queries higher up in the context, and they're sitting there, the results are sitting there in memory, and I don't have to recompute them. I don't have to refetch my 10 gigabytes of data to run my whole code again. It also records what you did, so it's really handy when geez, what was the outcome of that other code cell or the other execution the last time I ran this? You don't have to go search or lose a log file. It's always inside the notebook that you ran. And they're pretty easy to modify. Non-technical users can even modify an existing notebook, because you can even make interfaces within notebooks that hide some of the code, or even make very simple code like SQL that any user could do minimum learning to get into without being a full-blown software engineer. But there are some things that are not so good about using Jupyter notebooks. In particular, in the past, a lack of history. I made a change to a cell and I click save. Oops, I don't remember what that cell was. And you close your browser, you are not getting that back probably. They're pretty difficult to test, in the sense that I have a bunch of code and cells. It's kind of a glorified script in many ways. And if you don't structure it well, or have a placeholder to run unit tests, that can be difficult. It's a mutable document, so you're changing in place what's happening. So if you make a run and you save your outcomes and you rerun it, those outcomes can get lost because you overwrite the outcomes with the next run. So maybe if you're doing an experiment and you found a really good result, and then you tried a different experiment and forgot what you did to get that good result, you could lose that information, which is kind of frustrating. And then live collaboration, it only really exists in a few niche corners of Jupyter. In reality, if two people try to touch the same notebook at the same time, bad things happen. In the future, we hope that will not be true. So one thing we did when approaching this notebook space was we actually wanted to help start filling some of the gaps. In particular, we really liked the results linked to code, the visualizations being coupled with the execution context, and the ease of sharing. We had a lot of users who loved these aspects of notebooks, even outside of data science. But some things that really needed to be improved. Versioning was pretty rough. You didn't know what you ran last time you ran this notebook or 3 times ago. The mutable state kind of leads into that. The fact that when you want to use it in a production setting, you have to really be able to audit what happened, how did I execute it, what did I do, who authored this. And then templating. Most time templating before papermill came along was I share this notebook with another person and I give them instructions as a document at the top that says change this cell this way and then rerun everything and it'll run the way you want. And papermill helps solve that. So we're going to talk about papermill. Papermill is a library which has been gaining a lot of popularity. It's actually kind of just a lightweight wrapper on things that were already there, but it has a stronger opinion about how to do things. It's in a project called nteract, which is a collection of notebook repositories or notebook projects, which all add little enhancements to notebooks or make different components or things like that. So what's papermill and how's it do anything different? So one thing that papermill does is it actually isolates the inputs from the outputs. It's a Python library that has a command line interface, which lets you give an input notebook path. It'll compute that notebook, and then after it's done computing or hits an error, it'll store that notebook to a totally different place. It won't touch the input notebook unless you point the output notebook back to the input. So what this means is you can get some isolation between when you execute the notebook, what the template source was and what the outcome was. In this case, we see run 1, 2, 3, 4. So we were just iterating through maybe a loop, and we just saved each output to a different place, and then we can see what each execution actually did. All right, so how's this look in Python a bit, maybe? So in Python, it's a pretty simple interface. You import papermill. You say execute notebook, input path, output path. If you do this very simple thing, it'll work. And then you can actually see your outputs in the folder. Like in this case, I've put all the outputs in the outputs directory and just given it the date int as a prefix so I can sort by the date I ran this. You can also add parameters. This is the templating aspect we were talking about with notebooks. In particular here, maybe we have a notebook which runs some sort of analysis on, let's say, how many people are viewing a particular site on particular types of devices. And so here we've said, well, this notebook can take region and devices, so we're going to give it some inputs. What this will do when you actually execute this is inside the notebook, you're going to see we'll have a section in there. This cell execution 2 is something we defined. We said, hey, here's the region, and here's the device, PC. And then we calculate date sense. This is the default parameters. If that cell has been tagged as this is my defaults. And then when papermill executes, it'll inject a new code cell right below it with this. It'll look exactly like this. It'll say parameters, region California, and then devices, phone, tablet. So we took our input JSON-like object in the input and made it into code inside the actual notebook. So when it executes, it looks like someone typed in an extra code cell and injected in all the parameterizations after your defaults. And you can do the same type of input from a CLI. Matter of fact, we use this most often in kind of like any system that can call out to the command line, can execute papermill through almost the identical interface. In this case, we gave it region as a parameter with -p, and then we gave -y for YAML and just passed some JSON of give it all of this stuff. So we can see a little bit what this looks like if you actually execute it in a CLI. Here you see we have a file up here. If you can't see the red text, I made it as bright as I could before this, but the lighting is a little rough. If you can't see things, please do go look at the slides afterwards, and you can see a little better on your screen. So here we're executing papermill, and you'll see this is the default behavior. It'll print out the input path, the output path. It'll do a status bar as it goes. You can configure these things and control what it's going to output. And then we can do the same thing where we're going to give it these inputs, and you'll see essentially the identical input. Here we're giving it some conference, PyCon. And it'll print out a 5th cell here. So you see I had 5 out of 5 instead of 4 out of 4. So how would this look in Python? Similar thing, we're actually using a notebook to run a notebook. So this is kind of a fun thing you can do. And here I'm showing you the input notebook. This is the input notebook we were running before. It has some really basic things. It prints out an image, and it has some parameters called paper and mill, and it adds them together to print out a string, the most basic hello world notebook thing I could come up with that demonstrated everything. And here we have another notebook, which is going to run the papermill execute notebook. You'll notice when you're running papermill from a notebook, you get this nicer progress bar that's HTML. And here we're going to add a parameter in here. So we're going to change that mill parameter that defaulted to mill2. Now we run this, same type of execution. And if you go look at the outcome, you'll see this is the notebook output 2 that we made, and it has that parameter mill replaced with mill 2, which overwrote the cell execution 3, and now when it printed papermill 2 instead of papermill. So that's kind of the basic interface. There's a whole bunch of other components in there that we'll dig into. But how's this change the picture that we had before, where we had Jupyter being executed by users in a notebook server and a kernel? Well, it acts just like any other client in a sense. The papermill execution is just like a UI client. It's following the same protocols your browser server is taking to talk to Jupyter. And in this case, papermill here is reading in an input notebook, storing it in memory, and then it's sending each cell one by one through the kernel manager it launches to the kernel that actually executes the code. And it collects the results just like your browser would, and then saves them into the notebook just like your browser would. So at the end of the day, you can make all sorts of different types of clients that aren't notebooks that can interface with kernels in a way that's creative. And papermill just takes advantage of that. A little bit deeper into what's inside papermill that makes it work. It's just a slightly more complicated picture than the first one we showed with the input-output. You have notebook sources, which can be of many different schemes. And then it takes that source notebook. It has a register for how do I load this into memory. It'll load that JSON document into memory. And then the parameters will come in. It'll convert those into a dict in memory. And then it knows how to translate that dict for a variety of languages. And then it'll splat that back in as code in the execution. And then it launches this runtime manager, which actually goes and launches the runtime process, which is the kernel. So each time you're on papermill, unlike in a notebook, it launches a whole kernel and shuts it down at the end. So it won't have a shared context between executions, and it'll isolate memory and everything, and it'll clean up at the end because it's actually closing that process. In a notebook, when you're running a notebook, it kind of sits in the background and holds memory for a while until you either kill it or it decides you aren't using it anymore. In this case, you don't have that problem. But on the flip side is you can't reattach to that kernel. There are ways to change that or extend it. And in the output, you get these notebook syncs where you can save out to the same type of sources that you drew from. So now papermill actually lets you do things like maybe have a notebook that does something like analyzes confusion matrix over some machine learning process and says, hey, which one did the best? You can actually parallelize that execution and ship it out to a whole bunch of notebook executions with the same base template with slight variations on the input. This makes notebooks actually look a lot like a black box function. And then maybe you have a DAG that continues past this point. All right, so we kind of talked about what papermill did and what, in essence, it tries to achieve. It's a really simple library. It actually only has like 2,000 lines of code and 4,000 lines of tests, so you can actually just read all the source code. It's pretty simple. But what this actually changed for us at Netflix and for other groups in the world is that now the story about using notebooks can expand to more use cases. In particular, we had seen analytics engineers and data engineers and even platform engineers start to use notebooks for various tasks. And then the story was, oh, you wrote a notebook and did this thing. Cool, that's great. Rewrite it over here in this other library in this other way. And that was a pretty high friction point that we kept seeing with our users. They had a tool they liked, and then we told them to abandon that tool when they actually wanted to share it or use it in the platform itself. And so papermill was kind of an effort to sort of bridge that gap some and start reusing the technology and integrating the technology they like to use rather than complaining that it doesn't do what we like. And in this case, now these larger, wider group of users can actually use notebooks where they would have traditionally just written some Python script and threw it away someplace. Now they have a notebook which just gives them a more structured way of executing in a way they can share the code with engineers or their colleagues better. And it also is able to integrate into platforms. So a lot of platforms now support papermill as a notebook execution, so you can do things like schedule your notebook without rewriting anywhere else. The other nice thing with papermill is it's a very plug and play, so it actually supports all these schemes out of the box. So if you have a Google Cloud Store, any of the Microsoft Azure stores, S3, even HTTPS, which isn't shown here, you can connect to those and actually pull and read and write from those locations, and it just works. And as I said, with a plug and play, the really important thing with with papermill is it's designed so that it can be extensible to use cases we haven't thought of. So every single component of the library is actually a registered component by some key name that it goes and looks up what to do just in time in executing. So what this means is, let's say we want to implement SFTP. You think, oh, well, I got to fork this library and add a bunch of code and then figure out how to source code it back. Maybe it's something more proprietary, like an internal system you would never share back, but you need to figure out how to make it work. This is all the code you would have to write if you implemented read and write to add SFTP to papermill. And you wouldn't even have to like install a new CLI. So what this code basically reads as, you just need to make this handler for the input, the source or sinks. If you implement read, you can read. If you implement write, you can write. And then inside of your own package, you can use setup tools and use the entry points to add a new entry point, and then that automatically gets registered into the IO register of papermill. And then if you run the command at the very bottom where you say, okay, now I want to execute SFTP, you can point it at some SFTP server and read and write from it. That's how we implemented all those other schemes. Actually, teams from those cloud providers oftentimes just made a PR and said, hey, could we add this? And it was really easy. So other aspects of the library work a very similar way. All right, so we're going to dig into where some more value with using notebooks in places you wouldn't traditionally use notebooks. Failed notebooks in an ecosystem, like in a mature ecosystem, are actually really, really valuable. This is probably the #1 thing that has added value to introducing notebooks into our platform. And you may be thinking like, okay, I'm not sure why that would help. But let's say you had that same fan-out parallelization that we're executing, and the job number 3 here failed. So we scheduled this notebook template, we ran it a bunch of places, and number 3 failed. Okay, what's the traditional story for how you debug and fix this? Well, hopefully you have some tools that point you to some places, and you look at some logs, and you look at what code actually ran, and maybe you have to go like jump through some links and find what actually happened. Here, when we actually run a notebook, even if the notebook is just setting up templating for some other script to run, the output is actually a full encapsulation of exactly how it executed and how it failed, and associates all the logs with the individual code cells that actually ran. So if we look at something like the script on the right, where we have some execution that we're doing, where the code doesn't really matter, I'm going to jump by this. But let's say you're trying to create some table in SQL, and you have some code that helps you run that in Spark, and it blows up. Well, the thing is as you're prepping that code, you can print out useful messages and things like that. You traditionally do this in good software engineering, and then you would go read the logs. But maybe as an end user, that end user doesn't know how to get to the logs, or doesn't know how to associate lines in that log or the 5 log files to the code that actually ran. It can be a pretty complicated process for anyone who isn't used to these systems. So now, if you had that notebook run, and then you had this exception happen, which is a connection error, you couldn't connect to a host genie.typo, and you exceeded max retries. In this case, you actually get an execution failure, and you can actually take that notebook, clone it into your notebook dev cluster, execute it with any variation you want, find the issue, fix it, and now you can send that back, and you've actually got a full enclosed circle of I had a notebook outcome that was immutably saved, and I can clone that and run it exactly the way it ran elsewhere, and I also can see exactly how it failed and which parts of the code failed. And that's hugely, hugely valuable. It saves a ton of time on debugging, and I mean, it gets to the point where even we've had people who haven't touched code in years who end up on call, and then something went wrong, and they just said, hey, there was this link, I saw there's a notebook, I clicked it, and it was already clear what was wrong, and I figured out, oh, our table name changed, and I saw the table name error right in the notebook, so I just went and changed it, and everything fixed. It's really handy for a lot of users. So what this execution separation of inputs and outputs and templatizing has done is it's really added isolation for making immutable inputs and immutable outputs if you set up your system the way you like or the way you should. And it also allows the parameterization of notebook runs, and the configurable sourcing and syncing is really valuable too. So for example, when we run our scheduled notebooks, we default the output path to always be to a output path that has a unique ID based on the run and the date and all those other things in a GUID. So we have a collection of all the history of a particular notebook's execution in one place that we kind of look through and can read and see what happened. It also gives a lot better control of notebooks via library calls. Because papermill is a Python library here that you can just import and manipulate in other ways, you can do more fancy things like even replace how it executes to do other things. Like maybe you want to save it to another location before it actually runs all the execution. Or perhaps you really want to do something after it finishes running, or you want to inject more than just the input cell for the parameters. For example, there's one extension that takes it and says, oh, I don't really like keeping the default parameter cell. I always want to replace it and just put a new cell there. So they, like 20 lines of Python code, were able to change the behavior of papermill without forking and rewriting. And this is kind of leads into how notebooks are helping us integrate. So one thing I do want to make really clear: notebooks don't make good libraries. They're really good as an integration tool, and they have a lot of applications. They're strictly better in most cases than just making a Python script and throwing it in your favorite file store and then praying that that works in the future. You get more visibility and things like that. So it is a strict upgrade in many cases, but I'm not going to play down that if you make a really complicated notebook, it is going to be problematic for you because the unit testing space is not super great in this context. But notebooks are really good at building a result, taking a bunch of actions on various pieces of technology, and then kind of summarizing what happened and collecting errors and things like that. So it makes a really good integration tool for real production systems. So some development guidelines to keep if you're using notebooks in a critical path as opposed to maybe just enabling the user to not have to rewrite their things. So we use these kind of guidelines in writing notebooks for actual production execution for critical things. And this would be, you want to keep a low branching factor. It's difficult to test a notebook if it has many branches because you don't have the unit testing abstraction baked first class into notebooks. Short and simple is better. This is kind of true of all code. Keep one primary outcome. If you think of the notebook almost like a black box function, you should kind of have one result that you're trying to achieve. Kind of follow functional programming paradigms, leaves you in a better place. And then really try to leave library functions in libraries. I'm guilty of not doing this as much as I should, so do as I say and not as I do all the time. But it's a good indicator if you're seeing a problem with the notebook. For example, we have a template that runs, and occasionally it has issues because we've got some functions in there that are fairly complicated. It's like, oh, well, if this is important and we're running the issues and it wasn't tested very well, we should probably pull that out into its own library. So in that process, when you see these critical notebooks, you can slowly move things into a utilities library or a library that's associated with the notebook that you're running, and then you can do the proper unit testing there, and then make your notebook more and more of just an integration of libraries and API calls. So one place where we do also get a benefit where we didn't have good testing before is integration testing. So end-to-end testing of a notebook is actually really easy. You just call papermill on it with some dummy inputs. So here's an example where we're going to run papermill, and we're going to use this Spark template notebook that we were looking at before, and then maybe we'll save all our test run outputs to some test run IDE path, and then we're going to put in some fake things. So in this case, we're going to see how many people on the particular day from the moon watched our show. That number should be 0, but in the case of tests, you can do these kind of dummy tests and make tables that have data that don't make sense just to prove that the execution works. So here are parameters we actually get injected into the notebook are going to be region Luna, run date 2018-04-02, because I think I wrote that sometime around then. And then debug equals true. You can do things like, say, dry run if you want to avoid certain API calls or things like that. And then when you actually run your SQL, maybe your SQL statement that's inside your notebook is something like this, where you're inserting into a table where some run date is equal to the run date, and you're in the region that you actually want to run. And here, since we're putting in our debug information, we can do things like target our test DBs, target test data that we don't care about. So we don't really care about, did we get all the data and it moved over in this execution? We're caring that, hey, can Spark execute successfully? If we did care also about, is the outcome accurate? Because maybe it does some calculation in the notebook that's the notebook's responsibility. You could follow this by another job right after that would validate the results, or put a test notebook that would validate alongside the actual execution. So another thing I wanted to kind of talk about and dig into are some of the other ecosystem goodies. So as I said, Jupyter, since it defines a protocol and a spec, it actually has a wide collection of other libraries that help you do different tasks. And putting these things together is oftentimes the work of your notebook team at your particular company, where they'll try and get these pieces that fit the business needs that you have to support various actions. So these are a few. There's a ton more. I just threw a few that I've worked on or use a lot. MBConvert is a conversion tool we use that papermill actually uses for doing the execution. Commuter is a read-only interface for notebooks. Can't say how much how useful that is, we put all of our output defaults into a bucket prefix that is read-only, in the sense that we can launch and render these things for our users, and they can't edit the outcome, so they can just read what's happening there. I'll show you what that looks like in a minute. And then we have MB format, bookstore, scrapbook is another fun project which I'll show. And that's around like saving outcomes. So these are just things on more the compute side and like rendering, but there's also lots of other things on the front end side about different component libraries and integrations with different tools. So I'll talk really quickly just about one of these goodies called Scrapbook, which originally was functionality that was in the early versions of papermill, and we pulled into its own library. And what Scrapbook does is it lets you basically save the results, the data results, into the notebook object. So you can actually make the notebook also store what was the result in a programmatic way. And here I'll show you what this does. So it's only a few lines of code, much like papermill. It's not a super complicated interface. But here we're going to import Scrapbook inside of our notebook, and we're going to say scrapbook.glue, and we're going to say model result. So you have a model execution, and the model result is some accuracy value. I'm using a lot of machine learning metaphors only because the data science space has been really strong in notebooks, so it translates to some like real-world use cases you might have users asking to do. In this case, we save the model results into the notebook, and then later, outside of that notebook, we can go read the results of that notebook with this one line of code. So we can go read the notebook which ran, some ML experiment, run 71, and we can ask it for its scraps, which are all the things we glued into it, like our metaphor game here. And the scraps that we get here are the model results. We can ask for that by key name. So you could glue a whole bunch of things, model results, graphs. Matter of fact, in the bottom line here, you could actually put performance graph, or why did we pick that model? What was the information around it? You can save a whole PNG on the notebook and then re-reference it this way and re-render it elsewhere. And that's just a kind of nice little utility. If you're interested in kind of getting functional data results out of notebooks, I would encourage taking a look at that. Would love more contributors for various use cases we haven't supported yet. And then commuter is the read-only interface I was talking about. This is the commuter interface. This is our actually our integration template for running Presto jobs. That's the whole thing. Fits on one page. It's nice and simple. And this has a read-only interface when the user executes this notebook. This is the template they would see if they go click on the link for how's my job input look. If you look at the output, it would be this, but with all the actual log outputs right alongside it. And in this case, too, you don't need a like really expensive server or runtime launching. It just needs a server with basic JavaScript rendering. So a quick thing about notebooks at Netflix and how we use them, because I'm talking about the open source side more. So one thing we did when we started this project about 1.5 years ago to really deep dive into notebooks is there was this kind of strategic bet that notebooks is becoming a common interface for many of our users. We had lots and lots of analysts, lots and lots of data scientists, and more data engineers that were starting to use notebooks and then having friction when they came to using them. So we invested in a lot of areas of notebook infrastructure and tried to get really involved in the community and hire people from that community in order to foster the open source approach to how to solve these things. And since then, we now run over 10,000 jobs a day on notebooks. And they run like 150,000 queries or more at this point. And all of those are running on notebooks. And the way we've achieved that is by actually making like a simple templating of how they run a normal job. It maps into our notebook in templates instead of into like a traditional scheduler template you might see. So when they say, I want to run a Spark job, here's my query, we say, great, we'll take that. And when it actually runs and they want to see what happened or debug why it failed, there's a notebook link that shows them, hey, this is what we did. And this we've gradually like brought users into cases where notebooks are useful for them. They can also just schedule their own input path notebook and works the same way. So that's what I wanted to kind of share with you all, and definitely encourage you to go look at the open source projects we referenced. And the slides, I believe, are going to be, the slide link will be here, so I'll leave this up if you want to copy that. And here's a few interfaces to come talk to some of the open source groups on these topics. Thank you.
Thank you, Matthew. We have some time for questions, so if you have a question, please step up to one of these audience microphones. Please make sure to keep your questions directed at the speaker. If you have longer questions or comments, you can find them in the hall afterwards.
Hi, go ahead.
Hey, so if you have like engineers and stuff and they want to spin up a cluster and attach a notebook to it, like how does that work? Does it, you run notebooks locally usually, or Is there some way to spin up a notebook and a Spark cluster that you have automated?
Yeah, so the question was around like how do you connect when someone asks for a notebook, what do we do? In our case, we actually have a container launching service which launches a Jupyter notebook server for the user, and then they can connect to that. So whenever they want to launch, if it's already launched, we connect them. If not, we go make them an instance, and it comes up with the notebook infrastructure. And then it mounts the file systems that are shared between the systems. So if the user's saving things, they'll see it in their dev home directory as well. So we just kind of give them an experience there. And then the other thing we do is for those URLs and paths for hitting their custom notebook server, if they provide those to like the scheduler or another tool, we actually can translate via papermill, a wrapper on papermill, to go translate those particular schemes and paths into the source of file. So the user, when they want to say, hey, I want to use this notebook, can just give us the URL, and then we'll run it in other places.
It sounds awesome. Is that open source as well?
Yeah, you can do things with Jupyter Hub is a good like first starting point to go look, and it has really, really good tutorials they've made now for how to get Jupyter Hub launched in like 1 or 2 pages on all sorts of cloud platforms. So there was a group at Berkeley that did a whole bunch of work around that. I would encourage looking at that.
Awesome. Thanks very much.
Hey, great talk. Quick question. So for testing notebooks, I see the use case a lot of times for programmatic testing of Python outputs because that's more quantitative in nature.
Yep.
My question is, if you want to test, say, graph outputs where it's an image and you want to, that's something that you as a human qualitatively, assert, how would you go about asserting that from an automation standpoint, or even taking it further, like a JavaScript widget as an output for inside a notebook? How would you go about testing sort of those things?
Yeah, so what I would actually say in that case, if it's isolated all the way inside the notebook, I would look at maybe combining papermill and scrapbook, and you save the data results, the pandas data frame or whatever input that you built the graph with, and the visualization, and then you could run your test to say, hey, fetch the result out of the notebook. If it matches my assertions, great. If not, like render maybe the graph as well so you can see what it actually did, or the link to the notebook. We do a lot of integration tests where we actually run, and then we'll link it, though, to the run, the exact run that ran with a commuter link, and then the user could just go look at the notebook.
So it's always going to be qualitative in its nature, but just making that easier so that way it's just a few clicks to qualitatively assert it.
I think
right?
there's always a human involved when your
Right,
test fails, but to assert, I would look at like saving data with scrapbook if you don't already have a place to save your outcomes.
Okay, great. Thank you so much.
Yep.
Hello, I'm just kind of wondering, great talk by the way, I'm wondering sort of what best practices you guys use for doing things like dependency management when you're running notebooks?
Yeah, so dependency management is another sticky point in notebooks. I think it'll be better in the future. There's been a lot of push to make it more natural in notebooks to define dependencies. Today what we do to get around this pain is we actually have like a single image that we maintain as a team that has the majority of the dependencies for our users. And we do this not to satisfy dependency needs, but we actually do it so that our users get a consistent experience. So if they're running in their dev server, or they're running in the scheduler, or they're running someplace else, their notebook will have the same set of base dependencies. And then we give them tools for defining extra packages they want to use if they want to install them just in time or as they run.
Thanks.
Yeah.
Hey, you go first.
File format that takes the essentially plain Python file that just has the cell breaks as comments in the Python file. Does papermill consume that as well as a regular notebook?
It does not today. It'd be pretty easy to add it. And I think a lot of the tools that do that cell separation are adding in notebook export as well. So like Hydrogen and VS Code are both either have beta versions of that or will have it fully soon. So it could integrate pretty easily, but yeah, make an open source contribution, we'll add it.
Cool, thanks.
Hey, great talk. One of the issues that our team has had with notebooks is version control, like committing things to Git.
Yep.
And do you guys do anything to kind of do that, especially during the development process?
Yeah, so one place I would look is the version control story in Git isn't so great because you're diffing JSON, not because the diffs are bad. There's a few things you can, yeah. I think that the integration story there, like everyone wants to solve this problem, and there's lots of people trying to work on it right now. I did say there's a few things to look at today. Jupyter/NBDime is a really good library for doing notebook diffs. It's not integrated in all the stacks, and that's partially because things like Bitbucket and GitLab still need to add some extensions to their API to make it work within the UI. But if you're on GitHub, there's also some open source and closed source options that do extensions so that you can see rendered like two-pane diffs of notebooks where it's like highlighting the code in a notebook format. It's pretty nice.
Is that what Databricks is using?
What's that?
Do you have any idea if that's what Databricks is using when they have version control connected to it?
I am not sure what Databricks is using. I haven't looked recently, but likely they're using one of those 2 or 3 options that are out there, yeah.
Cool, thanks so much.
Hi, good talk. I was wondering, you mentioned about testing these notebooks. Does papermill have any sort of programmatic API for getting like the test result, like errors or like which cells are erroring out or any sort of that kind of information?
Yeah, so when papermill executes, it actually injects a whole bunch of metadata into the JSON document it's saving. So when it errors, it'll actually save that document one last time. It actually saves as each cell executes, and if the cell fails, it also saves. And it'll inject a whole bunch of error info and runtime info into the notebook object in the metadata. And that's the first place you can look. And then if it's more specific, I would look into like saving the data results with something like scrapbook.
Thank you.
Hey, so I think I think this makes a pretty good case for how to run notebooks for analytical data science type use cases. I'm wondering if you guys are using this approach for maybe more like production data engineering, like ETL jobs or jobs which are going to have like customer impact, or if your teams are still using maybe traditional type jobs for those.
So yeah, I would say, so actually when I said that scheduler project, almost all of our ETL is now running on notebooks, even if the users don't know it. So we've made a pretty big commitment to it. Like we run millions of notebooks now, as if you consider each run a different one. So that's definitely like taken off and done really well for us. I would say like users developing their own notebooks, there was some history there. That story's a little bit better, but I would say it's not a dominant pattern to do all your ETL work in a notebook purely. But we do try to like translate that into a notebook execution so that it's easy to see what happened. So like a lot of really important critical systems are running on notebooks now. I would say some of the more custom notebooks, there's a few that also do like their whole dev notebook style.
Hi, so I come from a scientific background, and scientists really want to collaborate on notebooks and have shared workspaces. Can you comment a little bit more on that?
On collaboration?
Yes.
Do you mean like multiple collaboration on the same notebook while they're working?
Yes.
Yeah, so that's actually probably something that will be coming. There's been a lot of discussion within the community, and there's a direction to go. There is one tool out there which already has real-time collaboration called CoCalc. It's really oriented towards academic use, so it's more like classroom type learning setting. So it has a few things that wouldn't work as well in a production like engineering space, but the model they have is really good, and we're probably going to pushing that model into Jupyter Core.
Hi, I'd like to follow up on the version control question with ETL.
Yep.
I'm blown away by your description that most of the ETL has been moved over to notebooks. What in practice are you doing in terms of storing and managing the source notebooks?
Yeah, so it's a mix. So all our templates that we use to say, hey, you can use this template, like Spark, Presto, and Transport, things like that, they're all checked in the Git, and then we have a big integration suite which runs papermill against all of those every time anything changes from any source. And then we kind of promote those through a standard asset promotion pattern you see with any kind of code asset. And then those become like the default template they can use, and then we can pin back to old versions. So it looks a lot like any kind of other dependency management sort of asset pipeline. For non-managed notebooks, like in the sense of like just the user's notebook, there's a few that we do encourage putting it in Git and then just referencing, but we also don't block people because we have a lot of analysts that don't quite know Git yet, or people that aren't familiar with it or don't have a team that's using it. And in those cases, we've been trying to work on a project called Bookstore, which is the new thing, which helps give you linear versioning automatically. By every time you save, it kicks off a unique version into S3 and just saves it there so that you can always go back and look at old versions. And then when we schedule notebooks, one thing we do is we copy that notebook in the S3 for that version, and we copy all the assets you reference. So if you say, hey, I need this file and this file and this file from Git, we copy all of those and bundle them into an asset bundle for the scheduled job that won't change even if Git changes, and we associate it back to that Git commit.
So if I understand, when promoted, you're mirroring
yeah, we
templates and
mirror it
assets
to the
from
Git
GitHub
commit
to S3.
Yeah, we mirror to the Git commit that code came from.
Okay, cool. Thank you.
I'm just wondering if you had any special tricks around authentication, particularly passing kind of auth tokens or other kind of credentials when you're calling one notebook from another, or does everything kind of run in a single authentication context when you're accessing different kind of data sources?
Yeah, so What we encourage and try to build tools to help with is we try to make it so that they can add secrets to their execution context without having it be in the notebook. So they might refer to a tool that's going to go try and load the credentials that need to be made. And we try to keep people from putting anything plain text or even encrypted into the inputs as parameters, because those are pretty prevalently visible. In general, for us, usually there's already tools for doing that in our platform, so we just integrate with those tools that are already there and make sure that the API calls you're making just kind of fall into those. There is some work on a few cloud teams that are doing to make interfaces that do this for you in a way in the notebook. There's not too many open source versions of that yet.
Okay, thanks.
So could we please get another round of applause for Matthew?
All right, thank you.